Hello, my name is Santiago, and today we're going to be reviewing problem 2 of exam 3. And pretty simple problem here. We're asked to find domain, range, and asymptotes of two following functions, a and b, and let's get started. So remember, we're looking for domain, range, and any asymptotes, if any, of the following functions. So we'll do a right here, and this function is f of x is equal to negative 2 x plus 1 minus 3. So right off the bat, you want to identify what kind of function you're dealing with. So we see that x is raised, so we know that this is a exponential function. Excuse my spelling. Both are misspelled, but that's all right. And you want to know what your basic graphs look like, so your parent graph. I like to write this down immediately because it helps me identify what the domain, range, and our HA would actually look like on the regular graph. And then we're going to mark our transformations and see how that affects our graph. So if we were to draw just a mock-up, doesn't have to be super crazy, a mock-up of what our graph would look like, right? Here's our x-axis, right? We have, I'm going to change to a little bit smaller. That is actually quite bigger, just kidding. We have our graph forever approaching this line here, and we'll talk about that here in a second. And we're going to hit through 1, and it's going to shoot straight up, exponential growth, right? And we know this also, this point is 0, 1. We know that there's an asymptote here as well. So let's change this to a dash, make it really small. We'll change color so you can see a little bit better too. Geez, this is not working with me today. Awesome. So there's an asymptote, horizontal asymptote at x is equal to 0. And it's this should be y equal to 0. Remember, because we're at the y value here, and this y value is always going to stay 0. Our x values will change, but our y value will never change here. So HA at y equal to 0 here. Get some water real quick, excuse me. And then we can also feel free to write our domain and range of this. So domain, right, we're looking at all x values. X is obviously right here, and it's going to be approaching negative infinity. And you also see x on the other side of the graph always approach positive infinity. Pretty simple stuff here. Then if we're talking about our range, we'll have a max cap at 0, infinity, negative infinity. Excuse me, it should be negative infinity to 0. And I'll explain that here in a little bit. I actually wrote this backwards. Sorry, my mouth was really dry. I had to get some more water. But you're going to see this actually is 0, infinity. And we're looking at y values here, right? So y is at 0 to infinity. Instead of maybe switching of some sorts, is because our y value will never be expanding past the 0. This is 0 horizontal asymptote, right? So as we're looking at this, our graph will forever, ever approach this asymptote, but will never get there. So we mark it as 0. And obviously when it goes from left to right, boom, spikes up to infinity. We can look at this very similar thing for the x values, right? Our x value will forever be increasing to our left, and this is going to be negative infinity. Those values will always go up, and then or down, I guess, if we're talking about negative infinity, and then obviously it shoots up towards infinity and will give us a regular infinity. Now let's get into the actual question of our graph. So you have to be able to identify what we're working with, right? So we have to remember the order that we do it to as well. We have always side shifts. So if it's in with the x, it's going to be a left or right shift. It's +1, so it's going to be a shift to, we'll do shift 1 left. Our next one can be whatever, anything but our vertical shifts. We want to make sure that we do our vertical shifts last. So we have a negative in front of the 2. So this is going to be a flip over the x-axis. It's in front of the x. If it was with the x, it would be the y. And then our last is going to be down 3. This one does stay true to the sign it's with. Pretty simple stuff here. So then you can actually figure out the horizontal asymptote from this, right? Because if our graph is shifting, so is our horizontal asymptote. So our HA is actually going to be -3. So that was pretty simple. And then we can actually base our entire graph off that. So we know our domain is actually going to stay the same. It's not affected here. So we should have negative infinity. Let me rewrite that cleaner. Negative infinity to positive infinity. And our range will be affected here, but since it's not 0, that asymptote moved down here to -3. We will have -3, comma, infinity. And that's how you answer the first part. Let's answer part B. And we'll use a very similar attack strategy. So we have g of x is equal to negative log 3 of minus x minus 5 plus 2. So a bit of a long one here. And again, it's important to know your parent functions. So you want to memorize the exponential and logarithmic functions just to make it a lot easier on yourself. And then we can apply our asymptotes. So if we're doing a regular log function graph, you look something similar to this. You have a vertical asymptote. That's important to know as well. Log we're always going to have a vertical asymptote, and we're always going to have a horizontal asymptote for exponential. Oh, why did I get rid of it? There it goes. My apologies. Let's get back into this. So we'll call this 1 right here. 1, 0. And again, we're going to see our domain affected here, right? Because that's going to be forever approaching that. And it's going to spike up and shoot all the way down, and so forth. It's important to note that this will affect the domain rather than the range from that we've seen last time. But let's mark our regular stuff. So domain, usually for this guy, let's think about it and logic it out, right? So from the left, it'll forever be approaching 0. So it should be 0, positive infinity. For our range, we can think about it very similar. Our range is going to be forever approaching up here and forever going down. So we actually have a negative infinity comma, infinity. Range will be all real numbers. Next thing that we could do is identify where the asymptote is. So we will have a VA, as I mentioned previously, at x is equal to 0, right? Because our x value is right here, and that's where the asymptote is going to be, at x equal to 0. Now we can list off our transformations. So again, you always want to start with inside the parentheses for shifts. So this will be shift right 5. And it doesn't matter what you do next as far as whatever you choose to do for your next order of transformations. I like to, of course, do this. I like to flip over the y-axis. It's a little easier to see for me, which this right here, if it's in with the x right before the x, it's flip with y. Flip over y, excuse me. Right, so we have a flip over the y-axis. Then, be like we've seen before, flip over x. Then our final transformation should be a vertical shift of some sorts, and this will stay true. So we're going to shift up 2 units. Simple enough, right? So let's talk about actually how that is affected, the domain and range and the asymptote. So again, it's pretty simple. You can kind of figure out and draft it in your head what's going on, right? So we automatically know range is not going to be affected here. So we can start off with that. That's the easiest one. Now let's talk about range, or excuse me, domain, and vertical asymptotes. So it gets a little tricky because we have a flip over the y-axis and over the x-axis. So it's going to get a little tricky, but we can do a little sketch pattern on the side if we get confused, right? So right now we start off with this graph, right? And we shift right 5 units, right? So our asymptote will now be over here on 5, and our exponential graph will be like that, right? Pretty simple, but now we have to flip over the y-axis. So if we do that, our new graph will actually look like this. Our vertical asymptote will swip to the other side, and our function will go like this. Now, if we apply the last one, which is going to be flip over the x-axis, our vertical asymptote is no longer affected, right? Because this is the x-axis. What is affected is the way that our graph will look. So if we draw it out again, it should have a weird look to it, similar to this. And then if we shift up, the last one doesn't really affect too much on either of our properties. We're going to shift up or down, and this would be shift up 2. So instead of what we're used to, it would be up here, and it would be affected like this. And we'll have our asymptote at -5. These are kind of really poorly drawn graphs, but it's just to sketch it out to get it in your head, right? Because then you can make assumptions upon your actual transformations and how they affect it. So we know that our vertical asymptote is going to be at x is equal to -5. And then think about how this would affect the domain, right? If we look at it, our first value will forever be okay approaching -infinity, no matter what, our domain. It's always going to be going this way. It's always going to be -infinity. There's no restrictions here for it, so it should be -infinity. But as we go up, we're going to be approaching this asymptote line, and that is -5. So we cap out our x value at -5. Pretty simple stuff. Draw a mock graph if you need to. Walk yourself through each transformation. Remember that if the negative is in front of the function, it's going to be flip over the x. If it's in with the x, it's flip over the y. Remember, shift left and right always come first, vertical last, vertical or down. Exponential will always have a horizontal asymptote, and a logarithmic function will always have a vertical asymptote, and vertical asymptote's x equals and y equals. Don't be afraid to logic it out and write down your thinking when you're doing these types of problems. Awesome. Thank you so much for your time.